Welcome back to the Mission Control Center here in Houston, where we now have to talk with us astronaut Mario Runco, who's going to tell us a little bit more about what Don Pettit's going to be seeing on the space station and what we might be able to see here on Earth as Venus makes its transit across the sun later today. Thanks so much for joining us, Mario.
Thank you, Brandy. Thank you, Brandy. Thanks for having me.
Well, okay, so we heard a little bit there about kind of what the transit is, but maybe you can tell us a little bit about your background, why you're interested in it, and why we should pay attention.
Okay, well, first of all, I was infected somewhat by Don Pettit and his enthusiasm for astronomy. My background is earth science, remote sensing, meteorology, and oceanography, and the connection between my background and my previous experience and now is since I was flying in space on the space shuttle, I have, with the International Space Station, been very instrumental with another team in the windows on board the ISS, particularly one, the lab window in the Destiny module. That is a science window for Earth science remote sensing exactly. We had proposed to have that on board in the early 90s, and it is now on board. And I was with the team that produced the Window Observational Research Facility. Dovetailing off of that with the WARF, by the way, is the acronym that's used with the lab window. Dovetailing off of that is the cupola window. We were part of the team that proposed having the cupola on board and its windows so that we could go beyond just looking at the Earth straight down underneath the station and be able to not only use it for operating the remote arm, the Canada arm on board the ISS, and for monitoring dockings and the like and berthings, but also use it for scientific and astronomical purposes, which we are doing for the transit of Venus today.
Have we been able to do that for any interesting events in the past that you would mention?
Actually, the cupola has been in use for quite some time since it's been on board. Primarily for Earth observations and the images that many people have seen probably of the Earth, quite spectacular. However, we've not used it in the mode we're using it now, where there are internal panes, kind of like your storm windows. You have maybe two windows. In this case, there are 4 panes of glass, but the innermost one is called a scratch pane, and that's a protective pane to keep the others very pristine. And that's not an optical quality piece of glass due to the plastic sheet on it. And so that one is going to be removed today for only the 3rd time. Prior times were for ISS engineering evaluations. This is the first time for science. So it's kind of a big event for us in the scientific community to be able to use the optical quality windows to the efficacy that's needed to bring out really sharp, crisp, detailed pictures of items. And in this case, Don is using an 800 millimeter lens, which is about 6 inches in diameter, the aperture. And for folks in real simple terms, is the larger the aperture on the lens or the telescope that you're using, or a pair of binoculars, the more it is affected by the window. So as that size grows, the worse the image becomes. So on a smaller camera, a smaller diameter lens, you don't see too much of an effect on the imagery that you might take. But on a bigger lens, the imagery really degrades quite rapidly. So we're hoping to get some really sharp images of the sun. And fortunately, Don, for this event, he knew about it. And I think Don, in many aspects, knows the goings-on of the entire universe in his head, and he planned ahead to bring the solar filter on board to be able to do this.
Good choice. We're excited to see what
Yes.
he gets. Now, I know this is not the first time that the people that we've been around for a few years have been able to see this, but it's the 2nd time, and before that it had been a long time, and it'll be a long time again until the next chance, right?
Correct. The last time was in 1760s, specifically 1761 and 1769. And at that time, as Don mentioned in the video, there was a scientific quest for this. This was kind of like among the nations back then, a moon race of the time, if you will, because to be able to measure the transits at the contact points, that is when Venus first enters the sun, and then when it exits, the tangency points between the two edges of the planet Venus and the sun, and you could through geometry, figure out by the distance and the angles the exact distance from the Earth to the Sun and Venus to the Earth, etc., and by that figure out the distances for the rest of the planets in the solar system. This was quite a scientific quest at the time, and the English, the Royal Academy, sent out James Cook in 1769. Actually, he left in 1768 from England to sail to Tahiti. And there's only certain spots on the ground that you could, like solar eclipses, you have to be in opportune places to be able to see the entire transit. And the French had sent out an explorer, Le Gentil, which was interesting. And Don mentioned in his video how he was gone for so long. What Don didn't mention is that he left for the 1761 transit, not the 1769 transit as Cook did. And the 1761 transit, he never made it because there was a British-French war at the time, so he couldn't get to India where he was headed to view it. He stayed out, which was what happened to him, why he was out so long, and why he was declared dead by his family when he returned. But he was going to go back to observe the 1769 transit in India. Cook was going to Tahiti, and in 1769 he got there, but it was cloudy, and he missed the opportunity.
That's got to be disappointing.
I'm sure it was. For all those years, 11 years, he was out. That was the previous one. The last one was in the 1800s, 1884, I believe, was the last one. And then the next one is 2117. And what's interesting, because of the orbits of Venus and the Earth, it happens in sequence well, it's regular, but it's not at equal intervals. For example, the next one's in 105.5 years. The last one was in 125.5 years. So if you go and carry out the cycle, it's 105.5, and then a pair 8 years apart, and then 125.5, and then the cycle repeats that way.
Okay.
That's because of the eccentricities of the orbits that we have.
But I guess we also our last or the first part of this pair was in 2004.
Yes. The first one for this pair was 2004. The ISS.
We had a photo just a moment ago.
Oh,
there it is again. The Trace vehicle getting some photos of that during its transit in 2004.
And the 2004, from a manned space exploration perspective, interesting. If I might digress for a moment, a piece of trivia is Gennady Padalka, who was on board now at Expedition 30, was on board Expedition 9 in 2004 with Mike Fink. And unfortunately, they did not have a solar filter. Neither of those gentlemen had the entire universe calculated in their brain as Don Pettit does, but they knew about it, and they tried to observe the transit and by indirect means, the pinhole box camera on a piece of paper to project the sun safely. They were barely able to do it because the angles to the sun were just barely visible. The ISS back then was not completed, and it did not have the suite of windows that it has today. We have much more opportunities for viewing in different directions with the windows on board now, which is why we're going to be able to see, hopefully, all of the contact points and even the center point. So it won't be visible the entire time, because even though we don't have to worry about the clouds, the solar arrays on the station as the sun transits the sky and the relative motions, the solar arrays or the radiators may block the view to the windows that we would need. But that would be very short periods.
Right. And we've got a few different windows that we can use. So we saw the live view of the cupola, which is one of the choices, and hopefully we'll have some good stuff. And you're going to be back with us later in the week, and hopefully we'll get to take a look at some of it then.
Right. Well, hopefully we'll see some of the images that Don takes. Now, his primary goal is to take the images out of the cupola window 1, which is the window that looks to port, and that window will have the scratch pane removed. So it's going to be, that's an optical quality window. The other two windows he's primarily going to use for when the view to the sun is in a different orientation is the Mini Research Module 2 that has a port aft-looking window, and then the docking compartment 1, which has a port forward-looking window. So that gives him the suite of view across the horizon for when the sun transits the sky relative to the ISS.
Well, I know he's real excited about the chance to see that in space, but hopefully maybe a few of us can see it here on the ground as well.
Right. If you're fortunate, and the part of the planet that will not see the transit at all is basically centered over the Atlantic Ocean. We are fortunate in North America and South America to be able to see a good portion of it. We will see it later today, starting at 17:09 or 5:09 p.m. Central Time in Houston, and it will progress, weather permitting, of course, and it looks like we will have good weather, at least here locally in Houston. It progressed till sunset, and if you're in the Europe region, European area, and east toward the Indian Ocean, you will see it at sunrise. So they will have seen it. They will see it for their time zones in the morning, and then over the Indian Ocean, for example, it's in the entire transit is visit. So if, for example, we were going to send out explorers and we were limited to ground observations, we would send sailing ships to the Indian Ocean, as they did at the time when Cook and Le Gentil went.
But we have a little bit better resources now. I know we've got the NASA Edge crew, I think, in Hawaii on Mauna Kea.
Right.
And they're going to be watching it live, and you can actually tune into some of that coverage on NASA TV starting at 4:30 p.m. Central Time today. Again, the transit itself starts at 5:09 p.m. Central Time.
Right.
So if you were going to try and see it, what are some of your tips?
Well, first of all, don't look at the sun. Do the standard safety briefing here. Let's see. I did have a set of glasses here. You could observe in the traditional ways that most people are more familiar with watching eclipses, solar eclipses, the indirect methods as the box camera, the pinhole cameras that I've said. But if you're fortunate enough, you can get a pair of these glasses. They're very cheap, and they're solar filter glasses. You can look directly at the sun with these. They cost about $1, if that. Unfortunately, there's not many places that sell them in most local areas.
So these are not 3D movie glasses?
No. Actually, it's the same companies make these. They just put in the different inserts for the solar filter as opposed to the red, blue, or the polarizing filters that you might use for 3D. These, for example, you can order online, but you would have had a thought ahead of time to get that. Even next day delivery is not going to help you in that case. If you haven't had the good fortune to do that, then another option might be welder's glasses. Now, welder's glasses come in a variety of colors, if you will. Not literally, but you would want number 14 welder's glasses, and those will protect you for looking directly at the sun. Now, in most areas where there might be an interest, trying to buy those glasses now in a Home Depot or a Lowe's or a hardware store, they might be sold out on them. For example, in Houston, when there's a storm approaching, or Florida, and a hurricane approaches, the stores sell out of plywood very quickly. You know, there's a run on those emergency type supplies. And in this case, there might be a run on the goggles for people who didn't plan ahead.
Well, I hope so. I hope that many people are interested and going to be tuning in or watching.
Yes, the transit of Venus is, as Don said in his video, is not scientifically significant nowadays. It's historically significant. We might be able, because of better technology and our observation methods, discern some new nuances of information, of scientific information about it. But it is a tool to generate interest in science, astronomy specifically, technology, space, and I look at it in a historical perspective. These transits, as I mentioned, come every 100+ years or so, and they're points in time that highlight the technology of the time. And the next time it comes, who knows what what we will be capable of. Hopefully, a lot more than we are now, and certainly I don't believe the ISS will still be orbiting the Earth. None of us will be here for the next observation, and folks then in 2117 and in the 8 years after that, in 2125, will talk about, as we are today, the history of observing the transits. And what gets me, as being in this control center and talking with you, is the poignant fact that the ISS now is part of that history, with Don and the crew making this observation. It goes along with Cook and Le Gentile and all of that history. So it's a demarcation of time every 100+ years apart. And that, to me, in the continuity, I mean, if you look at online, you could dig up, there's a catalog of transits that goes back to November 1998 BC. Okay, and then it's projected out to 3600
Wow.
you know, something like that AD. And so and here we're in, at least on the piece of paper that I had, we're in the middle of that timeline. So it connects us with history. It connects us with the future.
Great. Well, I hope that in 100 or so years they'll be using the photos that get taken today and talking about how we observe the transit then.
Well, great. Yeah.
Thank you. Go ahead.
I was just going to say that if folks go online and search on Transit of Venus, Venus Transit, one of the particular websites is Venus Transit, one word, .nasa.gov, and you can hunt around there. On that website will be some of the images that Don hopefully will have taken by then, starting this evening. And the team is ready to bring those images down as rapidly as we can and get them posted online for everyone to take a look at. Beyond that, there's a whole host of information out there, as I mentioned, and there's, of course, the website also is with the observations and the live webcasts that are going on from the Mauna Kea in Hawaii with NASA Edge.
Right. So to recap all of that, an easy website to go to is just straight to the www.nasa.gov site. It's linked from the front page there, and you can find all the various coverage areas and information sites available through NASA, straight from nasa.gov. And then, as we mentioned, we're going to be covering it on NASA TV tonight, starting at 4:30 p.m. Central Time, and we'll have regular studio updates and also the live coverage by the NASA Edge team from Mauna Kea in Hawaii. So all that to look forward to. Again, the coverage starts at 4:30 p.m. Central Time this afternoon, and hopefully we'll be able to talk with you again later in the week and get a recap of what actually took place tonight.
I look forward to that. Thank you.
Thanks so much for coming out. Again, this is Mario Runco, an astronaut here at NASA, and obviously a lot of good information on the Venus transit. Thanks so much.